Okay, so now we have to understand something important about database replication. Database replication is important for the point in time recovery and to reduce the workload on the databases. So all the databases are supporting this replication feature. Why replication is important? Because in case of disaster, we need the last point in time recovery. Uh, Definitely, we are taking the backup of the databases, but backup will not guarantee us to provide the updated data. So replication is important. So for the proof of concept, I am going to use here the MariaDB as a database, and I will set up two MariaDB containers to replicate the data, one as master, one as slave. Uh, the same practice you can apply on the VM levels, or if you are running these containers in the Kubernetes, so you can use the same practice, same configurations. Definitely, these databases should be in the different servers or in a different region or at least in the different zones. Here, for the POC purpose, I am running both the databases instances on the same machine. But in professional life, you will not use the same practice. You will place both the databases in different servers, and the server should be reachable to each other. So I created this Docker Compose file, and I am using the latest MariaDB database. So let's start. I have a Linux machine where I created this manifest Docker Compose. So in this Docker Compose, one is running on 3306 to expose the port for the external network. Second one 3307. Both are using the volume. One volume is for the databases related data, and one volume is related to configuration. So in the MariaDB and MySQL, all the configuration related files that are ending with .cnf we can place in this location. And for for the persistent data, I created a special volume for master and slave for the database related. For the configuration, I just created the directory at the same location just to access it locally. So, but you can do whatever you feel convenient. So, and the root password I set for both, I disabled the TLS. We will do another video to understand how to enable that TLS on the databases. So this is done, and let me just apply this. And one more thing we have to understand, I created these two directories, and these two directories does contain the configurational related settings for master and slave. And if I go in the master, let me show you whatever I have written in the configuration file. I create the replication.cnf file. Everything is given in the video description. You can see from there. So here, in the configuration of the MySQL daemon, I define the ID of the server. So whenever you are doing the replication, it's mandatory to set the ID of each database. So this ID will be unique in different servers. So I give the ID one as to my master server. Logbin file. Uh, this file will actually be enable the binary logging. Whatever is coming in this database, we are updating in this database will save in the database as well as in this binary file. The format of this binary file, you can say something like the file system, that how the data will be written in this binary file. The method we are going to use ROW. There are different other method, but this is the latest one and the best in sense of performance. We are using this. So data will be written in this file in this format, and server will create this file in its default database storage location with some unique ID I will show you. Then bin log do db mean which database you want to replicate actually. So here I will just change this configuration to, I am not going to use this setting because I want to replicate all the databases, all the newly created databases. And otherwise it will only replicate this test DB. And the expiry log days, this is important for the log rotation, mean these in the production environment there are a lot of transactions, so these files should automatically be rotated, and after every 1 day this file will be deleted. And you can set this according to your requirement. If there is some delay in the replication syncing in the slaves, so these files should be available to resync the data. So this is done. And for the slave configuration, for the slave I set the ID of this server to 2, unique from the master. And on this server I also set the MySQL bin, and it's not mandatory for the slave, but I enable this, or you can enable this if you want this slave server as a master of some other slave server. I mean, you want to do the chain replication of the database. One database, for example, you have 3 different zones. All zones have one database instance, so you want to do the replication. So one zone will uh, sync the data to the second zone, and second zone will get the data, update the data in the third zone. So these instances, this file will be used to be readable by another slave that is getting data from this slave. So, and then format is same, and this is the relay log. Mean whenever this slave will fetch the data from the master MySQL bin file, it will save in this file. First temporarily on the disk, then it will gradually do update in the database to avoid, mean the real-time data in the database will not go. It will first go in this binary file. And this is the log slave updates, mean requires if the slave is a master for other slaves. So multi-tier replication is mandatory. So we are not going to use a multi-tier. We are just going to create one master, one slave. So this is done. Configuration files are done. So let me just do docker compose up -t. It will spin up both the databases along with the networks we created, and docker uh, volume ls volumes are created, uh, docker ps, both the databases are up, docker logs, just to take the health status of databases. So MariaDB ready for the connection, it is up, database is in good state. Okay, so for the slave, this is also up and ready for the connection. Okay, great. So now we are done for the database instances startup process. Now we have to set up the replication. So far, what happened? Let me show you docker volume ls docker inspect volume. For example, this master volume, and this is the location where the master data is saved, and here you can see the bin file is created. So this is the binary file that is right now created, and it will save all the changes happen in the database. And for the docker volume ls docker inspect volume slave. In the slave, also binary file is created, and when we will start the replication, we will see the other file that I showed you in the slave, this one, MySQL relay bin. So MySQL relay bin is so far not created because the replication is not started so far. So let's now start configuration related to our replication. So we did the basic configuration. Now we have to make these database intelligent that they have to replicate. So master database, the slave database will connect to master database, and we have to create a user in the master database to be able, our slave reachable, connectable to the database by using the database user. So here I will use docker execute it, and I will jump into the MariaDB master and MariaDB hyphen u root. Password I set to password. I think let me just try. Okay, so I directly ran this command from the terminal. I am directly jump into the database. Let me just show databases. Okay, these are the default databases. So in the master database, we have to create this replicator user. So user is created, and then we have to grant some rights because this user is only responsible for the replication purpose. We gave the rights of replication slave and replication client, and on all databases we give star mean all database and second star mean all the tables of the database to this user, and percentage mean it's mean it should be connectable from the remote network. And the last command, we can do the flush privileges. Okay, this is done from the database side, from the master node side. Now, on the master node, we have to run this show master status. So, in the master configuration, we created this file I showed you. So, right now, this file is responsible to get to provide all the updated information about this database, and its position is 804. Its position, you can say that right now the state of the data, where right now applications are writing in the database, and at this time when we are going to set up the application, there is a specific state of the data in the database. So from this is just a position number, you can say, in this binary file. So from this position, it will start reading this binary file and will update the slave. So we get this information because we have to make aware our slave about these two very important uh, file and position. So we get this information from the master DB. Now on the slave, we will jump into the slave container MariaDB database, and the same root password I set on the slave. And here we have to run a query that will update in the database. So let me just first of all make this a one-liner query so that it should be easy to modify, or we don't need to do this activity, we just need to update here. the name of that database. It's MariaDB-master. So for slave, which host from which host it has to fetch the data, and which user it will use to connect with the master. We created this user, and I think I set the password same like this. Yes, I set the same password, and the port is 3306 because the containers are communicating with each other, and this database will be reachable because we set in the docker compose uh, both containers, and both container can reach each other by name. And which file will this slave will read from the master, and that information we fetch from this query. We have to update here, sorry, here, and the position from where it will start reading. So far my database is master node is static. I know there is nothing updated, but if you are doing this exercise in production environment, this value will change rapidly. So you must have to make some downtime until you are going to configure your uh, slave. So this value should be matching with the value of the master. And master connect retry is this 10 seconds. I don't know exactly this is 10 seconds or what is this value for time frame, but I think this is 10 seconds. Okay, so this is done. So I'm just going to run this query on my slave database. And line 1, there is something missing. Yes, a change 2 is also a part of the query. So here I ran this, and this information is now updated. Okay, so now I will show you the logs of slave, and in the slave log we can see the master connection name. Everything is updated. It's also reflected in the logs, and it will show us also the when the it will make the connectivity with the master. So now we have to run this command on the slave. So in the logs I showed you, now I am again going in the slave database, and I will run slave start, and again let me show you the slave logs. And here you can see this database is now working as a slave, and slave SQL thread initialized, starting replication. It will fetch from these logs this position, okay, and connect it to master. This is important. It is able to connect with the master by using this user on this port on this server, and this file this position, okay. So okay, now I am jumping back to my slave node, and we can also check the status of slave by running this command show slave status. Okay, if I run the command show master status, it will also show us some information. So master, this slave is also working as a master for the other, if you want to set up some other slave to fetch the data from this one. So because I enable these MySQL bin log. So this is also working as a master, but nobody is syncing data from this server. But we are only interested to see how it is working as a slave. So now it's waiting for the master to send events. Okay. and running, slave running, and this is a file name, this is a position we defined, and so far this file is also created on the slave that I will show you, and when I showed you the volume it was not there, and uh, everything is good, nothing is left behind, and just to volume master, and I will go in the slave, volume ls docker inspect volume this slave, uh, this path is for the slave, and this one is created right now when we start enable the replication. Okay, so now we have to jump into MariaDB master and show databases, and let me create a database just like test db, one row affected. Now I will jump into the slave db and show databases. So here you can see the test db is also created. It's real-time replicated. And from one I will go back to master, and I will run the same command, show master status. So you can see the position is changed. So it means something new happened in this file. Okay, and if you want to see the slave is updated in the real time, so you can run this command, show slave status \g. So you can compare this position 937 with this position. If these two are same and these two file names are same, these both file names are same, then it's mean the slave is in the real time. Slave is getting the data from real time from the master node. Okay, so this is done. Let me just do the final testing. I am going in the master database and I will use the test db. Let me show tables. So far there is no table, and I just gave in the video description these two commands to create a sample table and to put something new in this table, and show tables, and select star from this table, and we can see this one value is updated. Let me connect now to slave and show databases, use this database, show tables. Table is created, replicated, and select star from this table, and here you can see the data is updated. And just to show you again, the 1357 is the read master log position. And if I run from the master and show master status 1357. Okay, let me just quickly connect with the database and use this database and insert another value, test data 2, test data 3. Okay, and show master status, it's changed. And in the slave, show slave status, the position is 1859 1859. Okay, and use test db for tables. So you can see the data is replicated real time. So this was all about the replication. You can do this with any database, and with the same configuration it's replicatable. Right now this slave is not read only. You can also update the data here. Just I want to show you one more thing. For example, you updated in the slave. I updated in the slave another value, like I want to set 44 from slave. Okay, so these two entries I did from slave, but in the master, select star, you can see these two values are not updated because slave is only getting data from master, master is not getting data from slave. So we can also do, we can also perform some the security check, only this data is for should not be, user should not be update here. So how you will do this? You have some application running, and that application is connected with the databases. So to distribute the workload, you can route the select query to both the database. But for the update, insert, any change related queries should only go to master. So you can make your application intelligent, to distribute the workload to read the data from both the databases, and only modification from the master node. So this will improve your application performance because the most of the queries are related to the read the data. So that's why this will help you to also increase the performance of your database. So this exercise we did is for the point in time recovery and for the database workload distribution. So now if you lost your master node, you can get all the data from the slave node.